The next topic is autonomous driving. I will introduce the impact of artificial intelligence on vehicle driving. Autonomous driving solution, the essence of autonomous driving, and business prospects. In recent years, artificial intelligence develops from computing intelligence to perception intelligence and cognitive intelligence, which brings great impact on the traditional driving mode and transportation industry. Autonomous driving is an intelligent perception realized by sensing devices and AI algorithms. Tesla and Waymo's achievements in autonomous driving have sparked an earthquake in the automotive industry in Europe and the US. Intel's acquisition of Mobileye, Qualcomm's acquisition of Anthropic, and GE's acquisition have attracted China's attention. Since 2016, the autonomous driving industry in China has also begun to explode. Traditional auto enterprises have thrown out the intelligent strategy and planned to realize Level 3 autonomous driving in 2020. The picture shows the autonomous driving solution, which is made up of sensing, perception, decision-making, and cloud platform. The algorithm reads meaningful information from original data of the sensor to understand the situation and make decisions as the environment changes. The cloud platform provides offline computing and storage functions for driverless vehicles and can be used to train algorithms and update position map to effectively identify, track, and make decision models. Then I will introduce sensing, perception, decision-making, and cloud platform respectively. First of all, sensing. The GPS or IMU sensor system can help driverless vehicles complete positioning. The GPS is relatively accurate, but the update frequency is low. The IMU accuracy decreases with time, but has a strong real-time performance. Laser radar can be used to map, locate, and avoid obstacles, and it is often used as a major sensor due to the high accuracy. Laser radar can be used to generate high-precision maps and locate mobile vehicles. For example, the Volodina 6.4 beam laser radar can complete 10 Hz rotation and 1.3 million times per second reading. Cameras are widely used for object identification and object tracking. Cameras are used in line detection, traffic light monitoring, and sidewalk monitoring. Generally, there are multiple cameras around the body, which are scanned from the left and right dimensions. Next one is perception. The GPS update frequency is low, but the provided location is relatively accurate. The IMU position is insufficient, but can be updated at a high frequency. Some solutions combine the advantage to provide accurate location update. The camera can be used in a closed environment, and the laser light can be used to describe the environment in a shape. But it is susceptible to the distance of particles in the air. Therefore, The positioning is completed by a GPS or IMU, a camera, and a laser reader. Laser reader can obtain accurate depth information and is often used to identify and track objects during autonomous driving. The CNN network obtained through deep learning offline training and can be used to track approaching vehicles or human beings. Once an object is identified by CNN, CNN automatically predicts its action track. Collision is avoided during the driving process. The third one is cloud platform. The cloud platform provides support for autonomous driving on distributed computing and storage. Autonomous driving is still in the development stage. Simulation is the main means of low-cost testing. On the cloud platform, ROI's revisit simulation can be applied to nodes in the Spark cluster, greatly improving the simulation efficiency. The generation of HD maps invokes raw data processing, including point cloud generation, point cloud 2D reflection map, and HD mapmaking. On the cloud platform, Spark can integrate all phases into Spark jobs, accelerating access and computing, and greatly improving the performance of HD maps. Regarding assets of autonomous driving, there are two trends in the current autonomous driving patterns. Traditional auto companies tend to be progressive automation, and Tesla, Google, Baidu, as the representative of the technical companies, are using artificial intelligence to enter this field. The report from CITIC Securities predicts that in 2025, tech companies will get a 14% market in the smart car field, and the traditional cars will stick to 60%. Regarding the business prospects, the commercial potential of autonomous driving is to reduce transmission costs. Google, Uber, and Tesla are showing technological advances. Autonomous driving is about to bring a new round of revolution for car business. And even some believe it may be the biggest innovation in the auto industry since the invention of the internal combustion engine. TESS 2.0, the autonomous driving area, is a hot topic in the industry. Morgan Stanley reported that a driverless car would reduce the cost of carpooling from $1.5 per mile to 20 cents per mile. The overall scheduling is complete on the cloud. Ship transportation, customs clearance, highway transportation, and city arrival are completed automatically. With the help of autonomous driving, the efficiency can be maximized through reservation and carpooling. Cars of private ownership are changed to test operation tools. Those pictures show some business prospects of autonomous driving. Public transportation is most likely to take the lead in choosing a driverless vehicle. Baidu has obtained the autonomous driving experimental qualification in some areas. And some cities are still planning about from 30 to 40 blocks of autonomous driving areas. Research shows that each driverless vehicle can replace 11 conventional cars. Courier vehicles and parade trucks may be another area of driverless vehicles. The rise of e-commerce makes the demand for electric cars and trucks surge. Large cars costs are high, and autonomous driving devices are more profitable, which are more suitable for autonomous driving compared with private cars. And people who need special cars, such as elderly or disabled people, have a large demand for driverless vehicles. It is expected that Chinese elderly will account for 33% of the total population in 2050, and the US and Japan are expected to reach 20% and 40% respectively. Both groups focus on self-care and provide huge markets for driverless vehicles. The autonomous driving also has some obstacles. Heavy rain, university, or haze block the road signs will make it difficult for driverless vehicles to judge accurately. Water mist and sand dust affect the night radar sensor, block laser beam, and interfere with the camera, which affects the performance of driverless vehicles. The vehicle has been attacked by hackers. The threats to networked vehicles include human interference, ghost vehicles, and other malicious behaviors. For example, using bright lights affect the camera and radar. This behavior will cause artificial intelligence errors and bring serious dangers to passengers. Driverless vehicles require a spectrum of medium range below 6 GHz, which is difficult to ensure sufficient demand for such spectrum. Also, the 4G network has a certain delay. The maturity of 5G technology is the basic of driverless vehicle and IoT. Currently, consumers are still in the middle of accepting driverless vehicles. According to a survey by the University of Michigan, 46% Americans say they do not like autonomous driving. Laws must be formulated to ensure the security of driverless cars, such as lighting cameras, attacking computers, and sending electronic signals.